Alright, this video is for example 3 in our 2.6 notes. You should copy this into your note packet. I'm making a video for this so that you have another example when you're doing your homework, and it will also allow us to move on to other material on Monday, or other related material. Okay, so in example 3 we have a right triangle. This right triangle has sides of 30 and 40 inches, and the sides are changing. Write formulas for the area of the triangle and the hypotenuse of the triangle and how fast they are each changing. So let's just draw a quick picture. I'm going to make 30A and 40B. Okay, so we have A and B. C is our hypotenuse. This is a right triangle. Okay, so normally the area for a triangle is 1/2 base times height. But here in this problem, since we're dealing with a right triangle and we're going to be looking for the hypotenuse, we want to use the letters A, B, and C. So looking at our picture, a more appropriate formula would actually be 1/2, and then instead of base, use the letter A, and instead of height, use the letter B. So area equals 1/2 AB. Okay, now let's find the change of that area over time. So we'll take the derivative. So the derivative of A, and I'm using capital A for area because the lowercase a is a side length. So capital A for area over the change in time equals, looking back at our area, we have two variables being multiplied. That means that we will need to use the product rule. We know the product rule is f prime times g plus g prime times f. So take the derivative of 1/2 a. Derivative of 1/2 a would just be 1/2 times dA over dt. Again, using a lowercase a, so capitalization is important because now we're talking about the side instead of the area. Okay, so that's the derivative of f right there. Now let's add in g, so that would just be the letter b. So times b plus the derivative of b, which is just 1 times dB over dt times f, which is just 1/2 a. Okay, so let's actually write that in a nicer form. This gives us 1/2 b times dA over dt plus 1/2 a times dB over dt. So that's the formula that we'll want to use, this one right here, because it's in a cleaner format than the one above, for dA, capital A, over dt. Okay, now let's think about the hypotenuse. We can find the hypotenuse using Pythagorean theorem. So we know hypotenuse is c. Pythagorean theorem is a squared plus b squared equals c squared. We don't need to rearrange for c, we can leave it as is and take the derivative to find the change of the hypotenuse. So let's do that. So derivative of a squared over time would be 2a times dA over dt plus the derivative of b, so 2b times dB over dt, so the change over time, equals 2c times dc dt. Now I could factor out a 2 on this side. Let's do that. So I have 2 a times dA dt plus b times dB dt equals 2 times c dc dt. Then I can divide by 2. So divide this whole thing by 2, divide by 2. That way I get, well, let's cancel these out. The 2's cancel, 2's cancel. That way I get a dA over dt plus b times dB over dt equals c times dc dt. So we haven't gotten C entirely alone, but it's pretty close. So we'll be able to use that. All right, now we're ready to move on to the application. Okay, so in 3A it says the short side of the triangle, that's A, is increasing at 3 inches a second. That means dA over dt is 3 inches a second. And the long side, B, is increasing at 5 inches a second. So dB dt equals 5 inches a second. Okay, so the change in the area, we are going to need our change in area formula, which we had up here. Let's see, right here. Okay, so I'm going to rewrite that down here, and then we can plug in values. So we have dA over dt equals 1/2 b dA over dt plus 1/2 a dB dt. Okay, so let's substitute in. We have 1/2 b. B was our long side. The long side was 40 inches times the change in A over the change in time, so dA dt, that's 3 inches a second, plus 1/2 A, the short side was 30 inches, and in case you're forgetting where those numbers are coming from, it was back up here, the 30 and 40 inches that we were given originally. Okay, so 30 inches there, and dB dt is 5 inches a second. Okay, when we multiply that all together, 1/2 times 40 times 3 plus 1/2 times 30 times 5, we get that dA dt equals 135 inches squared per second. That's our final answer there. And we know it's inches squared because we're talking about area. We also know it's inches squared because there are inches here times inches. So inches is inches squared. All right, so we're ready to move on to the change in the hypotenuse. Let's see if I have enough room. Okay, we had our change in the hypotenuse formula here. We had C times DC. So I'll rewrite that formula. We have A times, dA, lowercase a, dt, plus B times dB over dt equals C times dC over dt. And we're looking for the change in the hypotenuse. That means what we're really looking for is just dC dt. But we can plug everything in and then solve for it. Okay, so A was our short side length, that was 30. dA dt we said was 3 inches a second. Plus B, the length of the long side, that was 40. Times dB dt, which is 5, equals our hypotenuse. Okay, now we weren't actually given the hypotenuse length. However, using Pythagorean theorem, we can solve for it. When we solve for it, we get 50. And then we can solve for dC dt. So dC over dt, excuse me. Okay, if you don't believe me about this 50, you can plug it in. Up here, 30 squared plus 40 squared equals C squared. This would give you 900 plus 1600, which is 2500, equals C squared. Take the square root, 50 equals C. Okay, so back to our problem here. Now we just need to plug or compute the numbers. This would be 90 plus 200 equals 50 dC dt. When we subtract 50 from both sides, see, we have 290, subtract 50, we get 240 equals dC. Okay, then we have 290, and we want to divide by 50 to get dc dt alone. So divide by 50 equals dc dt. And when we plug that in, we get dc dt is 5.8. And then when I think about units, we're in inches per second because we're talking about the change in the hypotenuse over time. Okay, so that's our final answer there. 5.8 inches per second is the rate of change for the hypotenuse. Okay, so let's finish the next part. All right, so our second example, the short side is increasing at 3 inches per second and the long side is decreasing at 5 inches per second. So here the short side A is increasing at 3 inches per second. That means dA dt is 3 inches a second. Oops, getting a little messy. And the long side is decreasing at 5 inches a second. That means dB dt is negative, because we're decreasing, negative 5 inches a second. Okay, now we're ready to plug this back into our formula for change of area. I'll rewrite the formula, but you don't have to. So the change in area, remember capital T, dA over dt equals 1/2 B dA over dt plus 1/2 A dB dt. So now we're ready to start substituting things in to find the change of area. So 1/2 B, our long side length is still 40. dA dt this time is 3 inches a second plus 1/2 A, the short side is 30 times dB dt, while dB dt is negative 5. When we plug that in, we get that dA dt is negative 15 inches squared, because it's area, a second. Okay, so that went pretty quickly this time. On to change in hypotenuse. Let's use a different color. There we go. We'll use purple. Okay, change in the hypotenuse. We have this formula up here still. I'll rewrite it. So A times dA over dt plus B times dB over dt equals C times dC over dt. Okay, A was the short side, so 30 times the change in A, which is 3 inches a second, plus B, the long side, which is 40, times the change in B over time, which is negative 5, equals the hypotenuse C. We found the hypotenuse was 50 times dC dt. And of course, dC dt is the change in the hypotenuse. That's what we're solving for. Okay, so when I plug that in, I get negative 110 equals 50 times dC dt. Divide both sides by 50 to get rid of this and get dC dt alone. When I do that, I get negative 2.2 inches per second equals dC dt. Ooh, T. Changed pages there. dC dt. And that's our final answer. Okay, so now I think you're ready to do the homework. We'll finish example 4 in class on Monday. It's very similar.